Hello, today we are going to be working on the January 2018 Algebra 1 Regents Exam. This is a video amongst many. We're going to be working on a couple of constructed response. So, just wanted to let you know that I am starting off with a reset calculator. You can get there by pressing second plus 712. Okay, so if we take a look, number 29 says, if the zeros of a quadratic function f are -3 and 5, what is the equation of the axis of symmetry? Okay, so there's a couple of key words here. The idea that these are the zeros of a function and that we're actually looking for the axis of symmetry. So the axis of symmetry, the equation for it is -b over 2a. If you take a look at the quadratic formula, it is the front of the top of the fraction and the bottom of the fraction. So it's without the plus or minus the square root of b squared minus 4ac. It's only the front. So what are we going to do with these roots and how are we going to use them to determine the axis of symmetry? Well, I can use b and a from a quadratic function when it's in this format, ax squared plus bx plus c. So is there any way that I can get to this format? Well, yes, because if the zeros are -3 and 5, that means that somehow I solved an equation that left me with x equals -3 and x equals 5. Well, that could have come from something like x plus 3 equals 0 and x minus 5 equals 0. So basically, I'm working a zero product property backwards. So, meaning, if I was given this quadratic equation, I would set each factor equal to 0 and then solve. So I'm essentially working backwards here. So I can multiply this out to get our quadratic equation. I'm going to get x squared minus 5x plus 3x minus 15. And we can change this to equals y now. And now we'll have x squared minus 2x minus 15. Now I'm going to apply this formula here. So a is 1, b is -2, c is -15. So I will have negative a -2 over 2 times 1, and this is really equal to 1. So this is the equation for my axis of symmetry. And it says justify your answer. All of this work brings me to this answer. So I am justified. Okay, the next example says the formula f of g equals a whole bunch of stuff. Calculates the gravitational force between two objects where g is a gravitational constant, m1 is the mass of one object, m2 is the mass of the other object, and r is the distance between them. Solve for the positive value of r in terms of the rest of the variables. So if I start by rewriting the formula provided, I am basically trying to rearrange this formula so r is by itself. So I can start by cross-multiplying. When I cross-multiply, I'll have fg times r squared equals 1 times g m1 m2. So if I want r to be by itself, I first have to undo this multiplication. So I'm going to divide by fg. I'm left with r squared equals g m1 m2 over fg. Now, to undo a squared, I need to determine the square root. So the reason why they told us the positive value is because technically when we take the square root of both sides, I can have a plus or minus version of the square root. But we only want the positive version, so we're going to ignore the negative. R is equal to the square root of g times m1 m2 over f little g. And that's our final answer. All right, so let's take a look at question number 31. At Mountain Lakes High School, the mathematics and physics scores of 9 students were compared and shown in the table below. State the correlation coefficient to the nearest hundredth for the line of best fit of these data. So if you want to determine the correlation coefficient, the first thing you have to do is turn your diagnostics on. So there are 2 ways for you to do this. If you do not have an updated calculator, you're going to press second 0 and then scroll to find diagnostics on and press enter twice. Okay, so I'll show you what that looks like. So you are going to go to second 0. That brings up the catalog. You're going to scroll down until you find diagnostics on. So we're almost there. And once you see right here, diagnostic on, you're going to press enter to select that function. And now I have to actually run the function, like sending the text. Like right now you just typed it out. You have to actually send it. So press enter. So now it's done. If you have an updated graphing calculator, you can actually press mode, scroll up, and then turn stat diagnostics on. So that looks like press mode. You see how I can say next. You can scroll down or up. I'm going to scroll up to get to the bottom of my list. And here's stat diagnostics. It's on because I already have it turned on. But you could also highlight it to press on or highlight off to press off. So either one. And you can press second mode to quit. And now your diagnostics is on. So how do we determine the correlation coefficient? Well, the correlation comes from when we run a linear regression. So first, I have to put all of this into stat edit. So this is going to be list 1 and list 2. So I go to stat, edit by pressing enter and type it in. Remember, the calculator is only as smart as the person using it, so be very careful when you're typing your numbers in. So 55, 93, 89, 60, 90, 45, 64, 76, 89, you get the point. Then I'm going to scroll over to list 2, type in our second list very carefully. In order to run a linear regression, I have to press stat again to get back to this menu. I'm going to go to the calc function and run a linear regression AX plus B because I'm looking for a line of best fit. So I'm going to scroll down to linear regression, press enter. This tells me that my X values are in L1. Yep, because we're using mathematics as X. Our physics is list 2, which is our Y values, correct. We don't have a frequency list. We do not want to store this equation, although you can. And we're going to scroll down to calculate and press enter. And here we go. So let's keep in mind that it asks us R is our correlation coefficient, and we need to round to the nearest hundredth. So I'm going to write out R equals 0.92154436338. And if we want to round to the nearest hundredth has 2 zeros, which means I want 2 decimals left over, and I have to look to the one next to it. This is a 1, which means I'm not going to round up. I'm going to round it. I'm going to leave it the same. So our correlation coefficient is 0.92. So if we take a look at the next, is explain what the correlation coefficient means with regard to the context of the situation. So the correlation coefficient is actually on a scale from -1 to 1. 0, if I have a R value of 0, then there is no correlation. And as I get closer to 1, there is a very strong positive correlation. And if I get closer to -1, there's a strong negative correlation. So 0.92 is very close to 1. So because of that, that means that we have a strong correlation or a strong relationship between mathematics and physics. So that's exactly how we can explain, but in the context of the situation means we're talking about math and physics, so I have to say something about math and physics. So what does the correlation coefficient mean? There is a strong positive correlation or relationship between mathematics and physics. Okay, I hope you enjoy. Thank you for watching A Heisey Creation. Have a wonderful day. Bye-bye.